Now we're going to look at integer exponents. When a number is repeated as a factor in a product, there is a handy notation that can be used to save time. So in my first situation right here, I've got 4 times 4. My factor is the same and it's been used as a factor twice. So I've got 4 to the second, or 4 squared. My next one, I have got 5 used as a factor 3 times, so we read this as 5 to the third, or 5 cubed. My next one, I do have 6 of those, 2 raised to the 6th power. Don't have a fancy name for this one. It says in these expressions, the small raised whole number is called the exponent, and it tells us how many times the number called the base is to be used as a factor in a product. So my base, that's my factor. The small raised number is called my exponent. Something sneaky you need to be aware of. In this situation, I have got negative 2 to the 6 equals negative 64. It says a negative in front of the base but not in parentheses is considered as subtraction and it carries over. That's because of order of operations. Remember, please excuse my dear Aunt Sally. So up top, if I first do 2 raised to the 6, this one that we saw a little bit earlier, so you put in your base, hit your caret symbol. Now, this is the old operating system. If your calculator does not look like mine in that you might have a little tiny box here, you've got the new operating system, which is really cool because yours will look exactly as what's on paper. That's 64. Now let's try the negative 2 raised to the 6th. It will raise 2 to the 6th because exponents come before subtraction, and the subtraction symbol carries over. Okay? Now if I put it in parentheses, that's a negative 2 raised to the 6th, and that will be a positive 64. So if it's out front, it carries over. Now we're going to look at some rules for exponents. I've got a double asterisk, and they are highlighted. So if I've got b to the first, well, I just write that down one time. So b to the first is just b for any number b. The next one, b to the 0, is equal to 1 for any non-zero number b. Well, let's try this one. Let's do 15 raised to the 0. Okay. Maybe 137 raised to the 0. What if I did a negative 137 raised to the 0? Now, if you remember back earlier, don't have it in parentheses, so the 137 will be raised to the 0 power, the negative will carry over. So I should end up with a negative 1, and I do. Okay. Next examples, we're going to be looking at some other rules, but I want you to look at how they came about. So in the first one I've got here, I've got x to the 4th times x to the 5th. So I wrote out by definition what x to the 4th would look like in expanded form, times, here's x to the 5th. Now to go back what I did a little bit earlier, my base would be x. It's used as a factor if we count this up 9 times. So that should equal x to the 9th. In this one, I've got a squared b cubed times a to the 7th times b to the 5th. Got rid of parentheses. You really don't have to reorder them. Some people like to get their bases, together, but it's up to you. Here I've got a squared. If I wrote it out, I'd have 2 of those, 7 of those. So in all, I would have how many of them? Hopefully you said a to the 9th. B, well, it looks like I should have b to the 8th. And I do. Alright. Now this is a binomial. You cannot send this exponent in. Not when you have a binomial. But now this binomial being in parentheses, it's considered a base. So this base is raised to the 12th power times same base raised to the 3rd power. So I can simplify this by keeping my base adding my exponents. So that's my first rule. This is called the product rule. If you've got a base raised to a power times same base raised to another power, you keep base, you add exponents. That's your product rule. Now this one's called your quotient rule. I have got y to the 6th over y squared. I wrote them out in expanded form. But when I have same factors in numerator denominator, I can cancel. So 2 of these will cancel with 2 of these. So in the denominator, since everything was canceled, technically I end up with 1. Up top I have y to the 4th. Well, y to the 4th over 1 is just y to the 4th. Now number 5, I've got 4 of the m's in the numerator, 7 in the denominator. Cancel 4 of these with 4 of these. So the numerator, I'm going to have a 1, and I do need to keep the 1 there. In the denominator, I've only got 3 of these left, so I should have 1 over m to the 3rd. Now see if you can do this one before I do it. Pause me if you have to. Let's see. My a's outnumber the ones in the bottom, so I'd end up with a squared up top. In the denominator, looks like the b's would end up down there, and I'd have 6 of them. So that should have been your answer. So my quotient rule, I actually split it up. Normally they use this one, but this, why I split it up, it does save us time. But we can end up with possibility of negative exponents, which I will talk about here in just a bit. But now, if my exponent in the numerator is larger than the exponent in the denominator, this is similar to number 4. You subtract going up. Or, if the exponent in the denominator is bigger, this is like number 5, then I would have a 1 in the numerator, and I would have a to the n minus m in the denominator. Actually, in number 6, I use both of these because the a's satisfied this one and the b's satisfied this one. So that's my quotient rule. Alright, let's see what happens here. Now in this one, this is the first time that I have seen a parentheses followed by a power. So by definition, this tells me to write what's inside the parentheses out twice. So I've got n to the 6th times n to the 6th. This goes back to my product rule. I have same base, I add exponents, so I'd end up with n to the 12th. See if you see a pattern here. In this one, this tells me to write this stuff out in parentheses 3 times, which I did. So I have m to the 4th times m to the 4th times m to the 4th. So by the product rule, I'd have m to the 12th. There's that one. My n, what do you think? Should have n to the 15th. This one, well, this tells me to write out what's in parentheses 4 times. So in the numerator, I have a to the, 20th? The denominator, I would have 2 to the 4th, but if you have a numerical base and it's not humongous, they want you to go ahead and find out what that is. So in the denominator, I should have 2 to the 16th. Gag-a-maggot. 2 to the 4th, which is 16. Forget it, I'm not writing this out. I think I'll go ahead, and it looks like what has been happening up here is multiplying. So this 20 is going to distribute in and multiply this exponent, so it should be a to the 60th. Can you imagine I have to write that out? Ugh. Now this one, be careful. This 3 is going to be distributed to all exponents inside, whether you see them or not. The 5, the 2, and the c all have an exponent of 1. So I have to distribute it to everybody. So up top, I'm going to have 5 to the 3rd, a to the 21st. Now, wait, before I do that, 5 to the 3rd, 125. So in the numerator, I should have 125, a to the 21st. the denominator, 2 to the third. Let's see, 2 to the third would be 8, b to the 15th, c to the third. Okay. So now this is the first time, like I said earlier, that I've had a parentheses followed by a power. Now, I had one earlier. Let me scoot up real quick. Right here. But if you'll notice, I've got addition here. This I cannot distribute. I only can distribute when I have what's called a monomial. Notice in these 5 examples, there's no addition or subtraction there. So this would be a to the m times n. This one would be a to the m, b to the m. And this one would be a to the m over b to the m. That's my power rule. So far we've had what happens when we have an exponent of 1, an exponent of 0, product rule, quotient rule, power rule. Well, let me look at this. I want you to see this because I did mention something about negative exponents. If I did a comparison here, notice my exponent in the denominator is larger, so I said earlier to subtract going down. But I also said that that first rule, this one right here, this one right here is used all the time, and you have to know how to deal with negative exponents. Well, if I do the base top exponent minus bottom exponent, if you'll notice, I have 6 to the negative 5, because that's what I get when I do 3 minus 8. So that means, since these two problems come from the same place, that means they have to be equivalent. So let me do 1 divided by 6 to the 5th. I'm going to change this to a fraction, so you need to know where your frac key is. Go to your math, and it's the very first thing. Hit enter, and then hit enter one more time. Not a nice number, okay? Let's see what 6 raised to the negative 5 is. If you'll notice, it's the exact same thing. Let's try 1 divided by 2 raised to the negative 3. Sometimes you'll get bases, it's just too large for it to do. So I want you to see that it does change it to a fraction. So now I did 1 divided by 2 raised to the negative 3, and it gave me a positive 8. Well, let me go down a little bit. Here's my negative exponent rules. If I have a raised to the negative, or raised to a negative exponent, technically that's over 1. To make it positive, you get the reciprocal, or you move it to the denominator. Now this one that I just did, I had 1 over 2 to the negative 3, which means I could move that up, so I'd have 2 to the third, which should give me my 8. So negative exponent rule, it will come into play. We don't leave anything with a negative exponent. There's only one exception, and we'll get to that, but majority of times you always change it to positive exponents. So that's all for this one. Thank you.